sprint for a bus, and within seconds you're breathing hard, your chest heaving to pull in more air. Strike a match, and a candle settles into a steady, glowing flame. These two things look nothing alike, but underneath, they are very nearly the same event, a slow fire that never goes out, burning quietly inside every living thing, and it goes further than you'd think. It begins with a simple need. Every living thing has to get the energy back out of its food. Food is stored energy. The sugar in an apple, the starch in a slice of bread, all of it holds energy locked away in chemical bonds, waiting to be released. To unlock it, your cells do something remarkably like burning. They take that fuel, combine it with the oxygen you breathe in, and break it down piece by piece. Out comes energy the cell can use, and two leftovers you already know: the carbon dioxide you breathe out, and water. That is cellular respiration. And notice, it isn't breathing. Breathing carries the oxygen in, respiration is the chemistry that happens once it arrives. But burning is only a picture. Look closer at the actual chemistry, and it sharpens into a single recipe. The fuel is glucose, a simple sugar. The reaction reads like this: glucose plus oxygen becomes carbon dioxide plus water and energy. Left to right, it really is just controlled burning, done gently in many tiny steps. Those tiny steps are the whole trick. A candle spills all its energy at once as heat. A cell lets it out a little at a time and captures most of it, packing that energy into a molecule called ATP. ATP is the cell's energy currency. Every time you move a muscle, hold a thought, or build a new cell, you are spending ATP, and respiration is what mints it again and again all day long. Push a little further, and you can ask exactly where inside the cell all of this happens. Most of it happens inside the mitochondria, tiny folded compartments that are the cell's power stations. There, along a chain of reactions, oxygen does its real job. At the very end, it accepts the spent electrons, and that final handoff is what makes aerobic respiration so rich in energy. When oxygen runs short, a muscle sprinting past its air supply, cells fall back on an anaerobic path that yields far less energy and leaves lactic acid behind. That's the burn you feel. And step back for the symmetry. This is the near mirror of photosynthesis. A leaf uses light to build glucose and give off oxygen. Your cells burn that glucose with oxygen to set the energy free again. So the heaving breath after a sprint and the flame of a candle really are one story. Fuel meeting oxygen, energy set loose. In you, that fire is tamed, banked into ATP, one careful spark at a time, the quiet burn that keeps every living thing alive.